Good morning. Hello everyone. Hope all of you are ready with your pen and paper to start indefinite integration part 2. We have done many sums yesterday. Today also we are going to do, and I have planned to cover up to partial fraction today. Hope all of you are ready. So let us start. Till this sum we did yesterday. Sum was x square plus 3 by x plus 1. Can you find the link? There we wrote x square plus 3 in this form, separated and then integrated. Hope all of you have understood all the sums I explained yesterday. Today we'll be discussing how many sums we can do by without substitution, and then sums will be started on substitution. Okay, most of these are based on substitution concept only, but we will not substitute anything. If we find it of this form, fx to the power n, fx is a function and its derivative there, then the result I will write fx to the power n plus 1 by n plus 1. Okay, we will write that. So I am interacting also with you. If you have any doubt over there, you can write at the instant. I will be able to see, because I have kept my another device also on. Okay. Hope all of you are attending, those who are supposed to do. Okay. So if we get this form, the answer will be fx to the power n plus 1 by n plus 1. Isn't it? Why? Because this form is like that only. If you have taken fx to the power n by another variable, then its derivative will be there, and the integration of this thing you have learned, x to the power n dx, you can put it in this form. Okay, plus c. For example, suppose we have a problem like this only. Here whatever given, you can see x to the power 5, 2 plus x to the power 6 to the power 4. If you take this one as fx, while answering you should mention which one fx and which one f dash x. Here fx is 2 plus x to the power 6. So f dash x is 2's derivative is 0, 6x to the power 5. Isn't it? So you can see that derivative of this part given there. If we have multiplied by 1 by 6 and then write to the power 4 into 6x to the power 5 dx, then this form, what is fx here? 2 plus x to the power 6. You can put it there directly. 1 by 6 outside. So it is fx to the power n plus 1, 4 plus 1 by 4 plus 1 plus c. Isn't it? So answer is 2 plus this to the power 5 by 6 into 5. This is 30 plus c. Clear? Understand? So whenever this form is there, you will be writing the answer straightforward. Similarly, another form is there. If there is, say, fx, just a minute, if there is fx and f dash x over there, f dash x in the denominator, then the answer going to be what? Answer going to be log of mod x, log of mod of fx plus c. If you have the integrand of this form, you have to just see that which one fx, which one f dash x. Suppose it is written the integrand is of this form. Just before starting these sums, I have collected for you. Before doing this sum, I have collected for you. I will be showing you the simplest one. Say there is e to the power x by e to the power x plus 4 dx. What is fx here? Fx, it is not necessarily true that it has to be there always in the denominator. It can be anywhere in our discussion. It can be anywhere. So this time that fx is lying in denominator, that is e to the power x plus 4, and then its derivative e to the power x is lying above. So if you mention which one fx, which one f dash x, then it can be done. Fx, let fx be e to the power x plus 4. What is its derivative? F dash x is e to the power x. This you can see. So this integrand is of the form f dash x by fx. Okay? Integration is of this form, f dash x by fx. Okay? So what will be the answer? Answer is log of fx. Here no need to use mod x. If you want to write, you can do. It will be log of mod of e to the power x plus 4 dx. Okay? Done? Now let's see what kind of sums are there waiting for you to be solved by you. See this one. Can you find fx and f dash x? Is it of this form? Which form? Either the first one or the second one. Either this form or this form. Here, n may be integer, it may be fraction also. We just notice that derivative of this part is given there. Okay? So let fx equal to x cube plus 2x plus 5. Then f dash x is what? 3x square plus 2. So this you write in the form what? This you take first. Fx to the power half. This into f dash x. Am I correct? Because this derivative exactly lying over there. What is the answer here? N is half over there. So you write fx to the power half plus 1 by half plus 1. Clear? So fx is what? Now put x cube 2x plus 5 to the power 3 by 2. This to the power by 3 by 2 plus c. So final answer you write 2 by 3 x cube 2x plus 5 to the power 3 by 2 plus c. Clear? Done? Go for next one. E to the power 2x plus 1 by e to the power 2x minus 1 dx. Do you find fx and f dash x here? If you can find, I have nothing to say. The derivative of e to the power 2x minus 1 is not the numerator, or derivative of numerator is not the denominator. Why? Because d dx of e to the power 2x minus 1 is nothing but 2e to the power 2x. Where have you got the derivative? It's not there. So what you have to do there? This you have to do a very small manipulative step. What is that? This is a very special problem. So what you have to do there? You multiply nr and dr by e to the power minus x. When you practice many sums, no, all these steps automatically you can write. Why have I done so? To get the form, one part fx, the other part f dash x. Let's see what is happening on this multiplication. Some may be given in various forms in your book. This is one of that type. You all understand the multiplication, being a class 12 student. So check derivative of which part is what. Is it coming of this form? That what I told you earlier, that f dash x by fx is there. We'll be writing the answer log of mod of fx. Is it there? You need to check. You just take fx equal to e to the power x minus e to the power minus x. So derivative is what? Minus minus plus e to the power minus x. Isn't it? So this is the advantage. See, if this integrand, if you want to write, this will take this very convenient form for you. That is f dash x by fx dx. What is its answer? Log of mod of fx. This is nothing but log of mod of. Clear? Understood? So answer to this problem, what was given, will be log of, this answer will be log of mod of this plus c. Understand? Go for next one. You try first, you'll get 1 minute time to solve it. Should start. How to do this one? You have to check which one is derivative of what. If you take fx equal to, taking fx equal to 4x square 2x minus 10, f dash x is d dx of this thing, 4x square 2x minus 10, 8x plus 2, 2 into 4x plus 1. Isn't it? So little bit manipulation you have to do before. Little bit manipulation you have to do before you use that form. This you multiply and divide by 2. It's coming of that form, no? This divide by 4x square 2x minus 10 whole cube dx. Clear? Just a minute. So this is half f dash x dx by fx to the power 3. You can write this as 1 by 2 fx to the power minus 3 f dash x dx. So this is that first form. Fx to the power n f dash x dx. Fx to the power n. N is what here? I remind you again, fx to the power n into f dash x dx. Formula, you know, we have started with this only. It will be n plus 1 by n plus 1 plus c. So here n is minus 3. Write it as fx to the power minus 3 plus 1 by plus c. What is fx over there? That is 4x squared 2x minus 10, right? 1 by minus 4x squared, this to the power minus 2 plus c. Clear? Understood? I think it's clear to you. You have understood. Okay? So go for next one. E to the power 4x plus 1 whole square into e to the power 4x dx. Do you find which one fx, which one f dash x? You take fx equal to, so f dash x will be what? 4 e to the power 4x plus 0. See, it is there. 1 by 4 is not there. So what you will do there? You will multiply and divide by 1 by 4. We have to get that from, no? So write 1 by 4 e to the power 4x plus 1 whole square. Clear? This is again of that form, fx to the power n f dash x. So answer will be 4x plus e to the power 4x plus 1 to the power 2 plus 1 by 3 plus c. These two you multiply. 4x plus 1 cube by 12 plus c. Clear? This is dx by 1 plus e to the power minus x. How to do it? For this sum also you need to make some manipulation before you solve. Okay? What kind of manipulation? What I am doing here, just multiplying both nr and dr by e to the power x. This is e to the power x 1 plus e to the power minus x, e to the power x dx by x minus x 0, so 1. This is of what form? Can you recognize? D dx of e to the power x plus 1 is e to the power x. So if you take this one fx, this is f dash x. So it is of this type, f dash x by fx dx. What's the answer? It is log of mod of fx. So you write log of mod of. For this particular function, mod is not compulsory. You may not write mod over there. Doesn't matter. Clear? Go for next sum. 2x square minus 1 by x into x square minus log x. Is this going to be a difficult one? Because fx and f dash x, can you recognize? Fx and f dash x, can you recognize? So do one thing, just derivative of x square minus log x, you think about this first. It is 2x minus 1 by x. Is it there? 2x minus 1 by x. Can you see it there? 2x minus 1 by x? No, not there. But we can get it on dividing by x. If you divide by x, it is 2x minus 1 by x by Clear? Now let x square minus log x equal to z. Oh no, we will not take. Okay, this you take as fx. We have to show which one f dash takes. So 2x minus 1 by x, if you differentiate, so this integrand is also of the form f dash x by fx dx. What's the answer? Log of mod of fx plus c. So this is log of mod of this plus c. Clear? Hope you have understood. Okay. Try next one. Try the next one. That is integration by substitution. This is very interesting. This is the pillar of your success in integration. If you can do this thing properly, then integration is done. What do you do in substitution? You take a part of the integrand as a new variable. Then differentiate. Check whether the remaining part coming that form only. So what I was telling you in previous two sums, it is of previous two types, it is of that only. But here I am not expressing fx f dash x like that, but because that may not work. So we will substitute a part of it by variable j, t, whatever you choose. Okay, let me do it. Before you do it, you can do some mental calculation. What is that? What mental calculation can be there? That derivative of minus 1 by x is 1 by x square. That we have seen. Derivative of minus 1 by x is 1 by x square. So if we take minus 1 by x as z, let this is equal to z. So what is its derivative? Its derivative is minus 1 x to the power minus 1, no? So differentiate, minus minus plus 1 equal to dz. Therefore 1 by x square dx equal to dz. So there will be e to the power z plus 1 dz. E to the power z plus z plus c. Z is what? Minus 1 by x. Am I clear? So the value of the integration is e to the power minus 1 by x minus 1 by x plus c. Understood? Go for next one. Again, you have to do it by substitution. If it helps, you check. Does it help? Or you can do it without substitution. Just I'll do a small change over there. You write minus sign over there. This is the sum. I hope some of you can recognize this, isn't it? How to do it? How to start this one? You let no part of this is derivative of the other part. So do some manipulation here. Divide by x square. Why I am doing so? Because I have seen that this numerator If you have divided by x square, no, so x cube you can take inside. 1 minus, just a minute, one more term I have to add here. This is my mistake, x square, typing mistake, sorry. So this is going to be what? If you take it inside, x square. Yes, if you take it inside, it will be x minus 1 by x whole square. Understand the manipulation? X square minus 1 whole square by x square by x whole square. This is separate. X minus 1 by x to the power 2. So put x minus 1 by x equal to z. So differentiating both sides. After substitution here, always you will differentiate once. Differentiating both sides. What do you get? One part of the integrand, this whole numerator is in the form of dz. And denominator is z square. So this you can do by writing z to the power minus 2 dz. Alright. So this will be 1 by z plus c. This is minus 1 by x minus 1 by x plus c. Clear? Understood? Ordinary substitution problems we are doing now. Okay? Go for next one. These sums I am discussing here, you won't be able to express f dash x into fx form. Okay? Or fx to the power n into f dash x form. So you have to make a substitution. What substitution you make here? Before that, you just check once. Numerator is x square into 2x. Denominator is x square plus 1 cube. So let x square plus 1 equal to z. You assume this. Let x square plus 1 equal to z. So what do you get differentiating? 2x dx equal to dz. Am I correct? You understand, I think? So now there is a problem. X square is there, but we have x square plus 1. So this x square you replace. 2x dx you write dz by z cube. Okay? This integration can be done by you, I know. So it is z by z cube dz minus dz by z cube. Simplify. Clear? You can integrate this thing easily. It is z to the power minus 2 plus 1 by, and this thing is minus 3 plus 1 by this plus c. So answer is minus 1 by z plus 1 by 2z square plus c. You put the value of z over there. Z is x square plus 1. This plus 1 by 2 into plus c is the answer. I mean plus c will be there in the answer, isn't it? Go for next sum. This is another brilliant problem. If you are not understanding, please write in the comment box. Question answer section I am checking regularly. repeatedly, but you are not responding over there. You must write your problem over there. Okay? If you have any problem. So go for next one. Brilliant sum. You think what way you will manipulate. If you are not able to think, then I have to do. x4 minus x to the power 1 by 4 by x to the power 5. You do one thing here. x4 you take common. x4 I have taken common. And here it is x to the power 5 dx. Why? It's up to you whether you will accept this method or not. I have thought this manner, I am doing it. You do it by different manner. But I think this is the best way to do. So integration x to the power 4 to the power 1 by 4, x cube to the power 1 by 4. What I told you yesterday, mathematics is always fun. Pure mathematics or applied mathematics. No, I am talking about mathematics. Both are mathematics, no? So, mathematics is full of fun. Mathematics can be made fun. But mathematics is not funny, isn't it? You have to understand your step, what you are going to take. If you have taken the step properly, then done. I have done the sum. Can you recognize? If I put 1 minus 1 by x cube equal to z, this implies, or you write, this implies differentiate this. Do you see something over there? This is dx by x4 equal to dz by 3. Isn't it? Is that clear? Understand? It's okay with you? Now you can write the integrand. This is in very convenient form. So I, the integrand, I mean this thing, it changed to what? This form. And that you can write now z to the power 1 by 4 into dz by 3. 1 by 3 outside, z to the power 1 by 4 will be plus c. Simplify it, 4 will go up. So 4 by 15, 4 by 15, z to the power 5 by 4. Z you substitute. 1 minus 1 by x cube. Alright. You'll find this book in most of the textbooks. Whatever. Okay. This kind of manipulation you practice with me here, apply it in solving other sums. How to do this one? You think before I put my hand for solving this sum. Think what to do. How to do it? Take something common again, like previous one. Here 5 is there, to the power 3 by 5 is there. Why you don't take common from there? Take x to the power 5 common. Am I right? Dx by x to the power 5 to the power 3 by 5. Is this correct? Check once. What do you find there? This is dx by x to the power 6. Okay, so put put 1 plus 1 by x to the power 5 equal to z. So this implies 1 plus, so differentiate both sides. What do you get on differentiating? Minus 5. Therefore, dx by x to the power 6 is minus 1 by 5 dz. Clear? So now substitute there. This is going to be of this form, minus 1 by 5 dz by z to the power 3 by 5. Minus 1 by 5 you take outside. So now integrate 1 by 5 by minus 3 by 5 plus 1, that plus c. Clear? So simplify it. This is 2 by 5 minus 1 by 5 minus half, z to the power 2 by 5 plus c. Put the value of z over there. Minus half okay, done. Hope you have understood. Think about the next sum. Dx by root x plus 2 plus cube root of x plus 2. How to proceed? Just check. How are you going to start? This is actually root x plus 2 is nothing but x plus 2 to the power half. Cube root of x plus 2 to the power 1/3, isn't it? So substitute there. Dx by okay, but now what to do? Now what to do? What way we can do it now? We have to remove both square root and cube root from there, isn't it? You have to remove both square root and cube root. So this can be removed simultaneously if we make a substitution. X plus 2 equal to z to the power 6. So dx is 6 z to the power 5 dz. So I equal to what? You put it there, 6 z to the power 5 dz, and this is z to the power 6. So z to the power 6 by 2 z cube. This one what? To the power 1/3. So this will be what? If you make the substitution, z to the power 6 to the power 1/3. This is z square. 6 outside, z to the power 5 dz by z square z plus 1. So this will be z cube dz by z plus 1. Clear? How to simplify this? This one you write z cube plus 1 minus 1 by so write z cube plus 1 by clear? Why have I done so? Because z cube plus 1, I am just writing here, z cube plus 1 you can write z plus 1 in this form. If you write it in this form, then z plus 1 get cancelled, isn't it? So write it and then simplify. So this will be 6 z square minus z plus 1 dz minus log of mod z plus c. Clear? So now replace z by what? Z is x plus 2 to the power 1 by 6. Am I correct? I have taken that only. X plus 2 z to the power 6. To the power 3 by 6 by 3. 2 by 6 by 2. 1 by 6 plus c. Understood? This way it can be simplified. So this was a brilliant sum. By making this substitution, we have reduced as much as possible. Go for next one. Dx by root 1 plus x. Root 1 plus root x, not x only. How can you simplify this? Start thinking. Is it possible? Or a standard integral is involved? No standard integral, nothing. You just make a substitution. What? X equal to z square. Just do it. Let x equal to z square. So dx is what? 2z dz. So I going to be 2z dz by 1 plus z. Because root x will be z only. Now take 2 outside. And this z you write z plus 1 minus 1. Yesterday's sum only now. After substitution, it is ordinary integration of the forms we have done yesterday. So write 2 into z plus 1 to the power half digit. This will be what? How can you write this? This I have written, then minus 1 by root z plus 1, which is z plus 1. Okay, write the step properly. No step jumping required. Minus 2 into dz by, clear? Done? So this is 2 half dz clear? This is the sum. Now integrate and substitute the value of z. So this will be 2 into half plus 1 by z plus 1 to the power plus c. Clear? So simplify. 2 will go. 4 by 3. Z is what? What you have taken the value of z? Z is root x. So it will be root x plus 1. And this is minus 4. 1 minus half is half plus c. Finished. Sum is done. Clear? Now for this one, dx by x square into root 1 plus x square. How to do it? Will you make any substitution there or without substitution? Can it be done without substitution? X square into root 1 plus x square. If you take 1 plus x square equal to z square, can be done. But do it that way. Let x square plus 1 equal to z square. Therefore, z by x dz, x is what? Z square minus 1 dz. So dx is z by root z square minus 1 dz, and x square part is z square minus 1. X square is what? From here you can write x square. Z square minus 1. So write in details, see what is coming over there, then proceed. Dx is z by root z square minus 1, z square minus 1, and this thing going to be what? Z. Isn't it? Into dz. So this thing getting cancelled, but there is another problem here. dz by z square minus 1 to the power 3 by 2. Now what? Is there any way? Is there any way to do this sum? So we can go for another substitution here, not x square plus 1 z square, it will not work. This thing will not work. This is a bit difficult sum. I set here for solving because here you need a trigonometric substitution. It is better we avoid it now. Trigonometry is not there in your syllabus, so I am deleting this part from your calculation. Don't do it. Go for next one. Can it be done without any other substitution other than just taking a part as z only? Can be done. I am showing you. this you write, this you write, just a minute, just a minute. Yeah, this one you write root 1 plus x square by x cube into x. Simple manipulation. You take in x inside. Inside, if it goes, it will be x square. So there will be 1 by x cube root. Now you make a substitution. This kind of form you have seen before. Put, what you are going to put? Put 1 by x square plus 1 equal to z square. So differentiating minus 2 by x cube dx equal to 2z dz. Okay? So 1 by x cube dx minus z dz. So I going to be what? I equal to, this you replace, and this is z, root z square, and this is very good sum, very important sum. So this is z square dz. Z cube by 3 plus c. Put the value of z over there. Z is what? From here. This to the power half. So this will be minus 1/3 1 by x square plus 1 3 by 2 plus c. Clear? So I am ending integration by substitution here. Okay? Because I have discussed all the types of sums given in your textbooks. 3 books I told repeatedly, that is NCERT support material, R.D. Sharma and M.L. Agarwal. You can approach sums on integration from any book after attending this session. Please do that and let me know whether you are able to do or not. And now I will give you integration by partial fraction introduction. This is actually for integration of rational expressions, like there is a polynomial in the numerator and here there are factors like this, x plus alpha, x plus beta, then cx, or c you don't take, x plus gamma or more. Normally 3 factors they give, or 2. This kind of integration can be done if you use partial fraction. By using partial fraction it can be done nicely. How to? You are aiming to write this one as sum of 3 or more expressions, rational expression, and then by comparison get their coefficients and then integrate. Like whenever this kind of thing is there, before you apply partial fraction, you must check whether polynomial in numerator has index less than the denominator. So to apply partial fraction, you must remember that degree of polynomial in the numerator is less than degree of polynomial in the denominator. If they are equal, then the method I am going to discuss with you will not work. If the degree of polynomial greater, then also it will not work. It can work, but you have to make some manipulation. Okay? So without telling anything more about this, let me show you one example how we'll use partial fraction for integration. Suppose this is the sum. I am showing you the introductory sum only. Tomorrow or some other session we'll do more sums. That kind of sums you require. But try to do with me today. This one. Your plan is to express this whole of integrand as sum of two rational expressions. You take 2x plus 3 by a by x plus 2, b by x minus 3. Okay? But a, b we don't know. If the integrand instead of left hand side you got the right hand side, then it is done. Everyone can do it. All these forms we have done. But how to get a and b? These coefficients a and b of 1 by x plus 2, 1 by x minus 3. You do cross multiply with this term. You write a into now you have to get a and b. To get a and b, put x minus 2. Put x equal to minus 2, it is minus 4 plus 3. This way is going to be 0, so b equal to minus 1 by minus 5, that is 1 by 5. You have to get the value of b also by putting x equal to minus 2. If I get a, then by putting x equal to minus 3, we get b. No, x equal to 3. 0, b into 5. So b will be equal to 9 by 5. Clear? So substitute there 2x plus 3 by this is equal to a. A is what? 1 by, oh sorry, both b we got. This is a only. This is a. A is 1 by 5. Value of a is 1 by 5. So this thing is going to be integration of a is a constant, dx by x plus 2, b is a constant, dx by x minus 3. AB value put there 1 by 5, this is log of mod x plus 2. B is what? We found 9 by 5. So 9 by 5 log of mod of x minus 3 plus c. Isn't it? So this way you can simplify the integrand. Even there is product of 3 factors. Say integrand of this form. 3x square plus 1 by x minus 1, 2x plus 1 into x plus 2 dx. How to do this? Product of 3 factors. No standard integral formula will work. So what you have to do? You have to write the same manner. The integrand, let 3x square plus 1 by x plus 2 is equal to what? A by the first, b by the second, and factors are linear. You put x equal to 1 on cross multiply, put x equal to 1, x equal to minus half, and x equal to minus 2, get the values of a, b, c, and then integrate. Okay? So, integration of introductory level you have finished. Now, what you have to do now after finishing this session? You have to start from your textbook, from the worksheets I have shared already or I am going to share, and then only you will be able to learn. Practice, practice, and again practice, then only you can excel in integration. And I remind you again, if you are good at substitution sum, you are good in integration. Whole of integration can be managed